In 1961, the Soviet Union started the legendary exploration of Venus with the Venera 1 mission. In 1967, we had the first real data about Venus that changed everything. In 1970, the Venera mission finally revealed the mysterious temperature and environmental characteristics of the planet. And in 1983, with the Venera mission 15, we finally obtained mind-boggling images of Venus's surface and how much it looks like Earth. But first, we will look at the number 1 mission that started everything, Venera 1. So, Venera 1, launched by the Soviet Union on February 12, 1961, was the first spacecraft to embark on a mission to explore Venus, the second planet from the Sun. Its primary objective was to conduct a flyby of Venus and transmit scientific data back to Earth. The spacecraft was equipped with instruments to measure cosmic radiation, magnetic fields, and solar wind as it journeyed towards Venus. Unfortunately, the mission encountered communication problems, and contact was lost with Venera 1 on May 19, 1961, before it could successfully reach its destination. Despite its failure to transmit data from Venus, Venera 1's pioneering journey marked an important milestone in space exploration, paving the way for future missions to the enigmatic planet. Venera 2, also known as Zond 2, was the second of 2 attempts made by the Soviet Union in 1965 to explore Venus, the closest planetary neighbour to Earth. The spacecraft was launched on November 12, 1965, aboard a Monier M carrier rocket from the Baikonur Cosmodrome. The Venera 2 mission was part of the Soviet Union's ambitious interplanetary program that aimed to explore the planets of our solar system. The spacecraft was targeted towards Venus, a planet which, despite its proximity to Earth, remains shrouded in mystery due to its dense cloud cover. This cover presents a significant challenge to astronomers and scientists, hoping to study its surface features and geological activity. After the launch, the spacecraft performed a mid-course correction maneuver on November 17th to adjust its trajectory towards Venus. Following a journey of more than 3 months, Venera 2 approached Venus on February 27th, 1966. However, due to the thermal control systems malfunctioning, the spacecraft failed to return any data, thus marking the mission as a partial success. Nevertheless, it was a major milestone in space exploration and served as a stepping stone for the Soviet Union's future endeavours in exploring Venus. And Venera 2 was not the first ever mission from the Soviet Union, because they had another mission before that on the Moon. For example, Sputnik, a small metal sphere launched in 1957, was not a mission to the Moon, but it had a significant impact on the space race and the Soviet Union's pursuit of lunar exploration. It weighed only 83.6 kilograms and marked humanity's first venture beyond Earth's atmosphere. The achievement of Sputnik was not just a scientific breakthrough, but also a psychological victory for the Soviet Union over the United States in the Cold War. It proved their technological capabilities to deliver payloads into space, including intercontinental ballistic missiles. Sputnik represented a new era where space was no longer an impossible barrier, but the next frontier for human exploration. Encouraged by Sputnik's success, the Soviet Union continued their lunar ambitions, leading to the Luna 2 mission in September 1959. Luna 2 was the first human-made object to reach the Moon, impacting near specific craters. Although it couldn't send data or images back to Earth, it marked humanity's first physical contact with another celestial body. Now, going back to Venera 3, it was a space probe launched by the Soviet Union on November 16, 1965. It was the first spacecraft to successfully enter the atmosphere of Venus and transmit data back to Earth. However, contact was lost with the spacecraft just before it landed on the surface, so no data was received from the actual landing. Venera 3 was a relatively simple spacecraft, consisting of a spherical main body and a conical entry probe. The main body contained a radio transmitter, batteries, and scientific instruments. The entry probe contained a parachute and a heat shield to protect it from the harsh conditions of Venus's atmosphere. Venera 3 was launched into the heliocentric orbit on November 16, 1965. After several months of travel, it entered the atmosphere of Venus on March 1, 1966. The entry probe survived the heat of entry and deployed its parachute. However, contact was lost with the spacecraft just before it landed on the surface. The reason for the loss of contact is not known for certain, but despite the loss of contact, Venera 3 was the first spacecraft to successfully enter the atmosphere of Venus and transmit data back to Earth. The data that was received showed that the conditions on Venus were extremely hostile, with temperatures of up to 462 degrees Celsius and pressures of up to 92 atmospheres. Venera 3 was followed by a series of successful missions to Venus, including Venera 4, which became the first spacecraft to transmit data from the surface of Venus. Venera 4 was launched on June 12, 1967, from the Baikonur Cosmodrome in the Soviet Union. It travelled to Venus on a 5-month journey, making a course correction along the way to ensure that it would hit the planet's atmosphere. On October 18, 1967, the probe entered the atmosphere of Venus at a speed of 11.5 kilometers per second. It was equipped with a heat shield to protect it from the intense heat of entry, as well as a parachute to slow its descent. The probe's instruments began transmitting data as it descended through the atmosphere. They revealed that the temperature was rising rapidly, reaching 482 degrees Celsius at an altitude of 50 kilometers. The pressure was also increasing, reaching 100 times that of Earth's atmosphere at the same altitude. The probe also detected a high concentration of carbon dioxide in the atmosphere, as well as traces of nitrogen, oxygen, and water vapor. The probe continued to transmit data until it reached an altitude of 25 kilometers above the surface of Venus. At that point, the heat and pressure became too much for the probe to withstand, and it was destroyed. However, the data that it transmitted had already revolutionized our understanding of Venus. Venera 4's findings showed that Venus is a very different planet from Earth. Its atmosphere is much thicker and hotter, and it is made up of mostly carbon dioxide. There is no liquid water on Venus, and the surface temperature is hot enough to melt lead. These conditions are not conducive to life as we know it, but they do provide valuable insights into the evolution of Venus and other planets. Also, building on the success of Venera 4, Venera 5 was launched on January 5, 1969, with a similar atmospheric probe, aiming to delve deeper into the Venusian atmosphere and transmit data until reaching 18 kilometers above the surface. The Monnier M, designed specifically for sending payloads into challenging higher orbits and interplanetary trajectories, successfully launched the Venera 5 on its course towards Venus. The interplanetary journey spanned over 4 months, including which Venera 5 travelled approximately 41 million kilometres. On May 16, 1969, Venera 5 reached the vicinity of Venus. At this point, a pre-programmed sequence of events was triggered to prepare the probe for its descent into the Venusian atmosphere. The spacecraft jettisoned parts of itself that were no longer necessary, such as its interplanetary cruise stage, to minimise mass and maximise the chances of a successful descent. Then began the crucial phase of the mission. Venera 5, now in the form of a spherical descent module, plunged into Venus's atmosphere. It entered the atmosphere at an angle to reduce the heat generated by atmospheric friction and to ensure a slow and controlled descent. The spacecraft was designed to withstand the high temperatures and pressures of Venus's atmosphere, and was equipped with a parachute system to further control the rate of descent. Throughout the descent, Venera 5 began transmitting data back to Earth. This information relay was the core objective of the mission, to directly sample the Venusian atmosphere and send that information back to researchers on Earth. The descent and data transmission lasted approximately 53 minutes. At about 18 kilometers above the Venusian surface, the mission ended as the probe succumbed to the extreme atmospheric conditions. Additionally, among the numerous missions to various celestial bodies, Venera 7, a mission launched by the Soviet Union to Venus in 1970, holds a special place in the annals of space history. It was the first spacecraft to successfully land on another planet and transmit data back to Earth. Though its operation on Venus lasted for just 23 minutes, the importance and implications of this mission are enduring. Weighing around 1,180 kilograms, the spacecraft was designed to withstand the hostile conditions of Venus and relay data about its atmosphere and surface. The journey from Earth to Venus took approximately 4 months, during which the spacecraft experienced a minor failure that caused it to lose its stability. Nevertheless, thanks to robust engineering and effective problem-solving, the probe was able to continue its mission and successfully approach Venus. On December 15, 1970, Venera 7 entered the Venusian atmosphere, descending towards the surface with the help of a parachute system. The probe landed at an estimated speed of 16.5 meters per second, tipped over but kept transmitting data to Earth. During its brief 23-minute operation on the Venusian surface, Venera 7 relayed valuable information back to Earth. The mission expanded our understanding of Venus, revealing key details about its atmosphere and surface conditions. These measurements turned out to be a revelation, showing Venus's temperature to be around 475 degrees Celsius, much higher than previous estimates. The Venera 9 and 10 missions were a pair of Soviet space probes that were launched in June 1975 to study the planet Venus. The two probes were identical and each consisted of an orbiter and a lander. The orbiters entered Venus's orbit on October the 20th, 1975, and the landers touched down on the surface on October the 22nd and 25th respectively. The Venera 10 lander landed about 2,200 kilometers from the Venera 9 lander. The images from the Venera 10 lander were similar to those from the Venera 9 lander, but they also showed some differences. For example, the Venera 10 lander landed in a region with more rolling hills and fewer rocks. The Venera 9 and 10 missions were a major success for the Soviet space program. They provided the first detailed images of the surface of Venus, and they made important measurements of the atmosphere. The data from these missions helped scientists to better understand the harsh environment of Venus and to develop new theories about the planet's formation and evolution. Moreover, Venera 15 and Venera 16 were twin missions launched by the Soviet Union in 1983, each equipped with a synthetic aperture radar, SAR, with the main aim of mapping the surface of Venus. Venera 15 was launched on June 2, 1983, and Venera 16 on June 17, 1983, both from the Baikonur Cosmodrome. They were launched 5 days apart to ensure that they reached Venus simultaneously and started their respective mapping missions at the same time. After their launch, both satellites took 4 months to reach Venus, arriving in October 1983. The main objective of the Venera 15 and 16 missions was to map the surface of Venus using synthetic aperture radar. The radar was used to penetrate the dense Venusian atmosphere and image the planet's surface, which was impossible with optical instruments due to the planet's thick cloud cover. This technique of mapping provided a detailed view of the planet's surface, which had never been seen before. Both Venera 15 and 16 entered Venus's orbit successfully and began their mapping mission. They were positioned so that they could map the northern hemisphere of Venus in complementary swathes, each covering an area from the North Pole to the 30-degree latitude line. Over 8 Earth months, they completed their mission, transmitting valuable and unprecedented data back to Earth. The data returned by Venera 15 and 16 provided scientists with an incredibly detailed view of Venus's surface. They revealed a dense and complex landscape, featuring vast plains, high mountain ranges, deep canyons, and many volcanic structures. These findings radically improved our understanding of Venus's geology and suggested that Venus is geologically active, a concept not fully confirmed yet, but supported by further missions and observations. These missions' data provided a leap in our understanding of Venus's geology, with a resolution approximately 100 times better than the best available radar images of Venus at the time. And it's important to point out that the Soviet Union had other significant achievements in space. For example, on December 2, 1971, the Mars 3 lander achieved an important milestone by being the first spacecraft to successfully land on the Martian surface. It sent back a series of images, marking a historic moment in space exploration. However, the success was short-lived as communication with the lander stopped after only 14.5 seconds. The exact reason for the communication failure is not known, but it is believed that a severe dust storm might have disrupted the lander's systems. Mars 3's data revealed that the surface pressure on Mars is much lower than that on Earth, and it has a mostly carbon dioxide atmosphere. The instruments on board also measured a surface temperature of negative 110 degrees Celsius, providing the first evidence of the extreme conditions on the red planet. And also, it is worth noting that Elon Musk has expressed interest in exploring Venus on several occasions. In 2017, he tweeted that he thought Venus was a more interesting place to go than Mars, because it was more Earth-like in its early history. He has also said that he believes there is a good chance that life once existed on Venus, and that we should explore the planet to find out more. In 2020, Musk's company SpaceX announced plans to send a probe to Venus, called the STARSHIP Venus Atmospheric Entry Probe. The probe would be designed to withstand the harsh conditions on Venus's surface, and would collect data on the planet's atmosphere, geology, and potential for life. As Musk said, "I think Venus is a more interesting place to go than Mars. It's a lot closer, it's a lot more Earth-like in its early history. I think there's a good chance that life once existed on Venus, and I think it's important to go and find out." It remains to be seen whether Elon Musk's plans to explore Venus will come to fruition. However, his interest in the planet is a sign that Venus exploration is becoming more mainstream. That's it for today. Subscribe to our channel and hit the notification bell.